This video is another application of the fundamental theorem of calculus. Find a function f of x and a number a such that 6 plus integral from a to x f of t over t squared dt is equal to 2 root x for all x larger than 0. Since we have an integral here, it's logical to differentiate both sides and apply the fundamental theorem of calculus. So we have d dx of 6 plus integral from a to x f of t over t squared dt is equal to 2 root x. And differentiating both sides, so derivative of 6 is 0 plus d dx integral from a to x f of t over t squared dt is equal to d dx of 2 root x. Now we know from fundamental theorem of calculus that the derivative cancels the integral. d dx from c to x f of t dt is equal to f of x. So derivative cancels the integral, the x goes inside where the t is, we get f of x over x squared. And here we're going to apply the power rule, so that's going to be 2 times and derivative of root x. That's just equal to derivative of x to 1/2. That's 1/2 x to the negative 1/2. So that's 2 times 1/2 x to the negative 1/2. The 2's cancel. We get f of x over x squared is equal to x to the negative 1/2. Let's cross multiply, and we get f of x is equal to x squared times x to the negative 1/2. And that gives us f of x is equal to x to the 3/2. So we have found the function, but we also need to find the constant a. So how do we do that? Let's plug x equals a into the equation and apply some theory. So we have 6 plus integral a to x f of t over t squared dt is equal to 2 root x. So we'll plug in x equals a. We get 6 plus integral a to a f of t over t squared dt is equal to 2 root a. But this integral is 0. Why is that? It's because the integral from a to a g of t dt is just 0. There's no area. If you look at the graph, here is g of t, here is t, and you just have a line, and the area of a line would just be 0. So we get 6 plus 0 is equal to 2 root a. 6 is equal to 2 root a. Root a is equal to 3. Square both sides, you get root a all squared is 3 squared, and we get a is equal to 9. So this is the value of a, and we found the function previously to be f of x is equal to x to the 3/2. That is a function, and this is the value of a. All right, thanks.